What I did, I grabbed one of these pictures. Remember that CAD directly from that we looked at directly from Lithuania, and do you see right here the ISO illumination curve? Do you guys remember? This is directly from the manufacturer. So if you have a CAD 400, a metal halide, 400 watt, here's the distribution pattern for this picture. Can you guys see that? That's directly from the manufacturer. We don't pay a whole lot of attention to it because of one reason. Anybody can tell me why? Because when we load the IES file of this picture into Visual, Visual will take into account all these curves. So I don't have to go in the old days. In the old days, guys, you know what they used to do? They used to grab all these curves and lay them out to scale on the top of the drawn by hand plants, right on the top of them. Imagine that amount of work. Now, thanks God, we don't have to. You grab into Visual, you grab the layout of your building from CAD, and you lay out right at the top of it digitally, right? So you don't have to do it by hand. Can I have thumbs up, Chad? Cool. Okay, so let's go into my presentation here. Okay, now we talked about fixtures. First, we talked about the light nature. Second, the lamps. Third, the fixtures, right? Now we're going to talk about the science of calculating lighting. Now you guys are going to start doing what Visual is doing. Cool? We already showed you the easy way, right? You guys already, everybody knows how to do by Visual, right? Yeah. Disclaimer. Now we're going to grill you how to do math by hand instead of using calculator. The reason why we do this, guys, the only reason why I do this is because you need to understand the fundamentals. But if you do this in the field by hand, you'll be fired the second day. Nobody does it by hand. But the reason why we do that one is really nice to do it, because then you understand the concept behind it. So you know how it's done, and then it's like when they teach us multiplication, right? And then you go to the calculator and you never do multiplication again, right? Okay, here's my chapter 4. Chapter 4 talks about calculation methods for outdoor industrial and commercial sites. Outdoor industrial and commercial sites. Before I go, I want you guys to write this. This is calculation. You guys have to follow up with your friend Chad. Okay, there are two methods for calculation. There's the lumen method. Does that sound familiar to you? The lumen method? That's what we did in Visual. Adam? Remember that? Oh, okay. When we did the lumen method and we dropped it, that's approximate method. And there is the point-to-point method. Two methods. Which one do you think is the more accurate? The point-to-point method. Okay. So here's what you guys are going to be doing here. To find how many lumen years, here's an example. I have an example for you. I have a room. My room is 30 by 20. A room typical to this, 30 by 20, right? 30 by 20. And I need to find how many fixtures do I need in this room. If the foot candle needed is 80, I need to maintain a foot candle 80. The area of the room is 20 times 30, right? That's the area. The lamps, how many lamps do I need in this? What type of fixture? I'm going to use 2x4, right above your head, the 2x4. How many lamps? I single-handedly, Mr. Curdy, decided to pick 3. Always 3, guys. You can go 2 or 4, but your cutoff is what? Start point is what? 3. 3. How many lumens coming out of each one of these lamps? Given. 3. So I decide, this is the IES file. I'm giving you the IES file here. 3,000 lumens. CU. Now CU, don't ask me too much about it. It's called coefficient of utilization. This is a function of the area. Ignore that one. It's just given. Let's think of it as efficiency. I'm giving you the CU as 0.7 given. Later on, we're going to calculate it. Maintenance factor. MF is maintenance factor. How often do you clean these lenses? Never. Right? Never. It goes to maintenance factor of 0.95. 0.95, guys, is clean environment. They keep cleaning them really good. The louvers, they clean the louvers, the lenses, everything. Reflectors are clean. Does that make sense? The maintenance factor. So M here is a maintenance factor. The maintenance factor is really good. Everything is taken care of. Can I have thumbs up, Chad, for maintenance factor? Okay. I can't emphasize. Everything in this side is given to you. Okay? Here is the area. Everything is in this side. And the question would be, Jeff, my friend, the question would be, could you please find how many fixtures do I need in this room? And lay them out. Before I go ahead and move on, everybody understand the foot candle are given. I want to maintain an average foot candle of 80. The area is 20 by 30. The lamps, 3 lamps in a fixture, that each lamp will give 300 lumens, and the coefficient of realization of it is 0.7. And the maintenance is really great. Maintenance factor is 0.98. They maintain these equipment and they clean them and do and service them and so forth. Given. Then you're going to take all this. By the way, that's what visual does. You're going to remember that light loss factor that you attach. That's equivalent to the maintenance factor. Maintenance factor, guys, it becomes light loss factor because we add other things to it later. Okay. All right. Here's the formula that you guys are going to write and not memorize. We'll bring it to the test. It says the foot candle, the number of fixtures equal the foot candle multiplied by the area divided by the lamps, lumens, coefficient of realization, and maintenance factor. That's it. To find the number of fixtures, you have to plug in all these numbers in this formula. Can I have thumbs up, Chad, for the formula? So your foot candle multiplied by the area divided by all of the following: the lamps, the lumens of each lamp, the coefficient of realization for the fixture, and the maintenance factor of the whole fixture. That will give you how many fixtures do you need. Any questions, any comments? Is that hard math? It's not really. Okay, so let's go ahead and I did the math here for you. Let me pick on Aaron. Aaron, what's the 80 here? Thank you. Let's go to Kerry. Kerry, what's the 20 times 30? Thank you. The 3. Joe, what's the 3 here? Lamb. 3, the 300 Adam. Lumens. How about the 0.7 Jeff, please? Coefficient of realization. I see you. Coefficient of realization. What's the 0.98? Venus. Darren is getting mad. Getting excited about it. Because he skipped you, that's why. Okay. You will after we go to chapter 5, because we're going to be calculating it. You'll remember it. Okay. Any question, guys, about how to put these numbers in the formula? Right? Aaron, my friend, you ace it. You just ace the test for the lighting. If you know how to put the formula in there. See how easy that is? Might as well go home and call it a day. Oops, no, not really. Okay. Mistake number 1 is when you plug these into your calculator. Please know how to use a calculator, will you? First you multiply the top, then you divide it by everything multiplied by each other the bottom. I hope you guys know how to use it. Believe me, I always have one order of operation. Thank you. I always have students, guys, who when you plug them in, they don't plug them right and end up with the right. Okay, I want you guys to verify that the answer should be 7.7 fixtures. 7.77. Okay. Now, Adam, can you buy a 0.7 of a fixture? Or a 0.7 of a boy or a girl when you have a child? 0.7 of a child? Like the American family is averaging now 2.3 of a child. Did you see the statistics? 2.3. When you did calculation and all the stuff. Anyway, so that's going to go where? Where are you going to go? Up. If you end up with 7.1, what are you going to do? Up. Anything fraction, you go up. Okay? All right, so how many fixtures do we need? 8 fixtures. Right here, exactly above your head. 8 of these. Any question, guys, about this? Can I have a thumbs up when you're done writing that stuff? 8 fixtures. How hard is that? Now, here's the area. I don't have visual with me, and I need to lay out 8 fixtures in this area. If I don't have visual, thanks God for visual. If I don't have visual and do the lumen, this is how the lumen method is. This is how you guys did the lumen method. Now remember, after you get the number of fixtures, the lumen method lay out the fixtures proportionally to get the best performance, right? Now, if you don't have visual, how do you do it by hand? That's the next step. So we know we need 8. We want to distribute these 8 into this area. How do I start? How do I start? Any question, guys, before I go to the next? I give you the rule of thumb for starting by hand. That will help you when you use visual too. Can I have thumbs up, Chad? Cool. Let me know when I can go back. Multiplying all this. Did you get? Because point 7 of a fixture is not a fixture. You have to go up.
So for every 75 square feet, 8 a fixture.
Did you do the math? Yeah. Now, here's the fixture that we're using. Could you please write, this is a 2x4 fixture, right above your head. How many lamps inside it? 3 lamps. Could I use a different type of fixture? Yes. My example is based on the most common, commercially common troffer fixture. Okay, so let's go lay them out. Here's how I lay them out. Look at this. I want you guys, before you draw anything, can you give me, I'll give you time to draw. First, take the 8. Do you guys remember how you factorize in school, how you used to factor 8? Grab the 8. The 8 is a number of fixture. Ask yourself, what are the largest 2 numbers that I multiply by each other to give me 8? Oh, first, what are the factors of 8? How do you get 8? You get 8 by multiplying 1 by 8 or 2 by 4. Is there any way you can get the number 8? Any other way? Right? Factors of, remember how we did factors in grade school? My daughter is doing it right now in 6th grade. Factor the 8. 1, 8 or 2, 4. And pick the one that gets you the largest 2 numbers. So 2 by 4. Very easy, right? Then the largest number of them will go into the largest wall. Which one? The 4 will give me 4 columns, and the 2 will give me 2 rows. Anybody knows why I made the columns 4 and the rows 2? Which side is the longest? The longest side goes with the largest number. Can I have a thumbs up, Chad? If you guys know that, you have just known how visual works. One more time. First, you factorize it. So get the factors, 1, 8. So either I end up with 8 rows, 8 columns, and 1 row. That's called stupid. Or I end up with 4 columns or 2 rows, right? Always you're going to end up with more rows and more columns if you can, because that will. Why do you think 8 columns and 1 row is not a good idea? It's not a good distribution of light. Good distribution of light, ideally, you want the number of the rows and columns to be equal. Ideally, right? But you can't get that one based on the area. Can I have you guys understand why did I come up with 2 rows and 8 columns? Now, Aaron, if that area was 50 instead of 20, then the rows will be the what? The 4, and the columns will be the 2. So the largest number goes with the longest distance. Can I have thumbs up, Chad? Because that's okay. So good. So based on this, I need 2 by 4. Here's how I start. 2 by 4, meaning I need 2 rows and 4 columns. There you go. Cut this by half. Here's my row number 1, row number 2, row number 1, row number 2. Questions for Chad? Okay, columns. Cut these, then you start here. 1, 2, 3. That'll give you column 1, column 2, column 3, column 4. 4 columns. Make sense? 4 columns, 2 rows. 4 columns, 2 rows. Then you go to the center of every, then you basically splitting it into rectangles, right? You're splitting the area into smaller rectangles. In the middle of every rectangle, you put a fixture. In the middle of every rectangle, you put a fixture. Cool? So I put a fixture in the middle of this. 1, 2, 3, 4, 5, 6, 7, 8. Make sense? Right? 8 slots for 8 fixtures. Are you guys with me? Cool? All right. Now that's not enough though. I need to identify the X and the Y so the electricians can go there and place them. Here's how you identify the X and the Y. So this distance, the rule, guys, is the distance from here to the center of the fixture is X. The distance between the 2 fixtures is 2X. When you put a fixture, the rule, when you put a fixture, you go from the wall, guys, 2 feet, and between the 2 fixtures, 4. The distance from the fixture to the wall is half the distance between the two fixtures. That rule can give you the best distribution. Can I have thumbs up, Chad? Okay, based on this rule, I have from here to here, I have 1x, 2x's, 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 1x. Okay? So 1x, 2x's, 2x's. So that's the rule. And x 7.5. This is just the distance. We did the x as a distance between them, 7 and 10. Okay, so we have x is at 1, 2, 3, 4 divided by 37 and a half. 7 and a half is just that distance. And then we cut it by half. Okay, this is what we did it. We did it slightly different. Let's look at this one, guys. So if you find this distance is x, 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 and x, 4 x's equal 30, right? This distance, all of them are the same distance. So x divided by 30, that gives you 7 and a half. So from here to here is 7 and a half. From here to here is 7 and a half. So in order to get half, 7 and a half. So 7 and a half from here to here. To get half of it, what do? You divide it by 2. So when you divide it by 2, you end up from here to here is what? 3.75. Same token. These are y. Y, y. Cool? So here's 2y is equal 20. Divide, so y is 10. So from here to here is 10. So what do you think from here to the center of that? Half of 10, that'll give you 5. You can see how we got that 5 and the 3.7. Now, I'm sure Jeff is looking at me and said, you lost it, Chad. How about the grid? How about the grid? What we're going to do, if this is 3.75, it's not going to match the grid. These are guidelines. This is if you don't have a grid, that's how we place them. If you have a grid, then you shift. Here's what you do. Suppose they have a grid, and you guys are going to lay out this one. So from the top, it's going to be 5. So I'm going to come from this. I'm going to go, okay, what is it? 2 plus, this is, let's say 2 plus 2, 4, half of this 5, and start. So you might not be able to start in the half, so you have to shift it to what? To the other. So long story short, guys, if you have a grid, you have to readjust these numbers to match the grid. If you don't have a grid, then you just put them exactly where the numbers are coming. One more time. We divide this area into 4 x's, right? 4x divided by 30 give you 7.5. So from here to here, 7.5. To find the center of the x, that divided by 2 give you 3.75 from here to here. Between the two fixtures is y is 7.5, 7.5, 7.5. The last thing here will be what? 3.75. From the y distance, the same thing, the 2y give you, the y is 10, half of the y is 5, between the two fixtures is 10. So my fixtures will be mounted at 5, at 3.75, 3.75 and 5 to the corner, and 5 in between, and 7.5 in between. Can I have thumbs up, Chad? Okay. Now here's Carrie. Carrie, why do you think I orient the fixture this way, not the other way around? Yeah, but you orient them. The reason why you oriented them this way, because you orient them with the number, the longer distance. Look at the longer distance. This is longer distance here. You make the longer distance match the longer side of the fixture. Otherwise, you flip the fixture the other way. Okay? If it's a square, it doesn't matter. It can be either way. Can I have thumbs up, Chad? We fully understand how this works. Okay, so that's my calculation for my fixtures. Calculation for my fixtures. Okay, so everybody understand the Lumen method? Everybody understand the Lumen method? We did the Lumen method. That's how we do them. We're going to do a couple of calculations like this as we move on, guys. Okay, now the rest of it, guys, is what is the maintenance factor? What is a maintenance factor? They define the maintenance factor. These are just how they define the maintenance factor. If you look at the maintenance factor definition, guys, It's made out of DDF, and you're going to learn a lot of acronyms here. DDF, LMF, LLD, and TF. Okay? These are all factors. Now, what the heck are these, Chad? I've never heard of them, right? Remember that 0.7 that I threw it at you and I said, just stick with it, will you? Where was it? 0.7. Here. No, not 0.7. 0.98. Remember that 0.98 that I gave you guys? Take it. This calculation for this number. This is how they calculate it. Bam and bam. Okay, maintenance factor equal DDF is dirt depreciation factor. How often do you clean your fixture? 0, you're dirtier than a pig. And clean, you're cleaner than a doctor. Is that a good comparison between a pig and a doctor? Is it a better way? If you're an engineer, you're closer to the pig than a doctor. Oops. We're being recorded here too. Okay, you guys understand what the DDF? So how do you decide what the DDF is? DDF. You're going to look at the environment. There's some criteria. They give you, there's factors for different environment that they give you different values for the DDF. Otherwise, for me, I will be giving you guys these values. You will be given these values. The DDF and all this good stuff. The depreciation factor. Give me 1 second, my friend. I'm coming with you. The depreciation factor, movers. Okay, so DDF is dirt depreciation factor, 0, dirty, 100% clean. LMF is lamb mortality factor. Mortality factor. How often these lambs are going to die in you? Are they going to live for a year, 2 years, 3 years, right? So this also goes from 0, no relambing, into 100% we relamp every 6 months. Because these lambs are going to die eventually, right? We're all going to die eventually. The lambs are. So for you, a lot of companies, guys, at least 6 months to a year, typically year, they relamp everything. They go relamp the whole fixture. So do you think they're going to die on you if you relamp them every year? No. If you are like us here, done we live them for a year, for 10 years, they're going to die. So that has to be counted into consideration. There's a factor. Cool. Can I have LMF factor? The second factor is LLD. What's LLD? LLD, lamb lumen depreciation factor. That's from the manufacturer. When you say lamb, the mortality really it's part of the lamb and the fixture. Yep, and the ballast. Yeah, that's the mortality. But what dies most of the time is the lamb. Lamb dies more than the ballast. But yeah, every certain, I don't know what the ballast is, probably 5 years they change ballasted. But lambs, relambing a yearly or 2 years is common.
Increases the mortality rate of the lambs when the ballast starts getting bad.
Absolutely, absolutely. Now, lamb lumen depreciation factor. When you guys put this lamp, the 3000 lumen lamp day one, do you think after a year it's going to be giving you the same 3000 lumens? It's going to go down. So manufacturers will give you a curve. They say after a year, assign a factor of 0.8 lamp depreciation factor. So from 0 factor all the way to 100 manufacturers factor assigned to the lamp. That's done by the manufacturer. Can I have thumbs up, Chad? Okay. The last factor is temperature factor. Temperature factor, I see graph for temperature factor. Change lamp depreciation, temperature. If you guys look at page 42, there are temperature in degrees in Fahrenheit and percentage of mean rated lumen. Can you guys see temperature in degrees? At the best performance of the fixture is giving at what? At 60 degrees Fahrenheit. Can you guys see that graphic here? This is a graphic. It will give you the best amount of lumens at 60. Now, if you put that sucker at 100 degree Fahrenheit, you're almost getting 82% out of it. If you go put it at minus 20, this particular fixture, you will get nothing out of it. This must be a fluorescent fixture. Now, these are just idea, for comparing reasons. So that factor has to be taken into consideration. Cool. So when I gave you the 0.98, I took into consideration all these put together in one factor. Can I have thumbs up, Chad? Okay, so let's go back one more time and review these. So maintenance factor is dirt, depreciation factor, how often you clean. Lamp mortality factor, how often you re-lamp the fixtures. Lamp loss, what do you call LLD again? Lamp lumen depreciation factor assigned by the manufacturer. And TF is the temperature factor. Are you burning them at an ideal temperature, which is close to 60, 72 room temperature? Or are you burning them at higher or lower? You can see at the higher temperature, it goes down. At the lower temperature, also goes down. Okay? Can I have thumbs up, Chad, for all these? So that's where the MF came, maintenance factor, came to be. Okay, so let's go to, we talked about these boys. Okay, now I'm going to go to point-to-point method calculation. So there are two calculations in lumens. You do calculation by two methods. One is the lumen method. You guys have just finished that. Let's go back again. Remember that method here that you did? You're perfect. You can use this formula. Done. That's called the average method, the lumen method, the poor man's method, the poor man's method, average method. If I ask you right now, Kerry, my friend, what is the foot candle right at this point here? Can you tell me? No. But you can tell me the foot candle average is 80. If I ask you what's the brightest point in this room, can you tell me from the average method? No. It can't tell you the brightest and the dimmest point. It can't tell you. It only tells you the average. Why? That's why they call it lumen method, average, poor man's work. Though it's easy. Now let's go to the rich man's work. Anybody rich man here? The rich man's work. This is called point-to-point method. We're going to take an example, point-to-point method. That's how visual guys does it. When you do the calculation, when you draw the solid, and you did the calculation zone, and you put your fixtures, and you hit the button and start crunch, right? It was crunching numbers. That's exactly what visual was taking every foot by foot. I think it was 2 feet by 2 feet. The corner of every 2 by 2 square, taking it and doing a calculation right at that particular point to get you the brightest point, the dimmest point, and the average, and a couple of ratios. This is called point-to-point method. Okay, we have an example with you. The example is a high-pressure sodium, 150, mounted at 10 feet, and maintenance factor of 90. Remember the maintenance factor we calculated? Given 90. And I need to calculate the foot candle at 0.1, at 0.3, and at 0.2. The formula that you need to use is not the first formula. They have a different formula. Here's the formula you need. Foot candle equals CP, candela power, lumens. CP is candela power, multiplied by cosine Q, multiplied by the maintenance factor, divided by the distance squared. Here's the distance. If you write this one, you're going to write it once and ignore it because we're not going to use it. Here's the one that we're going to be using. If you guys take the cosine of an angle, equal the cosine of an angle is the opposite over the adjacent. So if you do the opposite over the adjacent, you're going to end up with H. Here's the angle here. If you take the cosine of this angle, it's this side over this side, right? So cosine equal H, the height, over the distance. If you flip it and put it in this formula, and I trust the Adam is going to do that, flip this, find the distance equal H over cosine, plug it into here, you're going to end up with this notoriously famous formula, that big boy here. It says the foot candle at any point equal the candela power, lumens, multiplied by cosine Q raised to the power 3. Raised to the power 3. Raised to the power 3. Multiplied by the maintenance factor, divided by the height of the fixture. One more time. The candela power at any point around the fixture equal the lumens coming out of the fixture, multiplied by cosine the angle. Where's the angle? Right here. You're looking at the angle right here. The angle raised to the power 3, multiplied by the maintenance factor, divided by the height of the fixture. Can I have thumbs up, Chad? Gentlemen, you have just entered the point. Huh?
Squared.
This one?
No,
Oh, h squared. Thank you. H squared. Absolutely. H squared. This formula here is coming actually from this after you substitute the d into this formula. Anybody can prove it. Plug these here and you should end up with this formula. The one that I'm going to be testing you guys, the one that I'm going to be using is this boy here. Okay. One more time. I have a fixture mounted 10 feet and I need to find the calculation right underneath the fixture. And I want to go, I think, I can't remember what the distance I gave you. I think 10 feet, right 10 feet this way and 20 feet the other way. I will give you the distances here. So at point 1, point 2, and point 3, and I'm actually adding point 4 too. So let's go do the calculation, will you? Before we go there, let me repeat myself one more time. I have a fixture, high pressure sodium, 150 watts. And I single-handedly asking you to do the following. Find a foot candle at 4 points. Point 1 right underneath the fixture. Point 2 at an angle of point 2. The angle for point 2 is 45, guys, at 45 degree angle. Point 3 at 65 degree angle. And point 4 at 25 degree angle. Does that make sense? So here's on the fixture, and I want you guys to put right here in front of me at this angle, and this angle in both sides of the fixture. Any question? Let's go calculate it. Now this is called the point-to-point method. That's what visual does. Point-to-point method. This is the notorious, the famous formula that you guys are going to be using. Notorious, the famous formula that you guys are going to be using. Okay. Any question, guys, about the arrangement here? Let me repeat. High pressure sodium fixture 150, mounted 10 feet. The maintenance factor for this fixture is 90, including all the factors, their depreciation, luminol, temperature, blah, blah, blah. All lump summed as 90. And I need you guys using this formula, this red big fat formula. After you derive from these two, put them together to come up with this, I would like you to do the calculation on these 4 points. Point number 1 is at 0 angle. Can you guys see this one is at 0 angle? Goes right underneath the fixture. This point number 2 at 45 degree angle, 65 degree angle 3, and 25 degree is point number 4. Shall we go to the calculation? Very easy, straightforward, no gimmick, nothing. I promise you. Darren, my friend, that's a new science to you, probably. Did you guys do calculation like this? Now you appreciate visual. Do you guys appreciate what visual have done to you? Imagine that they used to do it in the old days this way. Okay, now let's do it the old days. Okay, here we go. Gentlemen, I'm going to give you enough time to write. I said foot candle at point number 1. Everybody knows where point number 1 was, right underneath the fixture. Everybody's thumbs up, Chad. Point number 1. Now at point number 1, the angle is what? 0, right underneath it, because we're measuring the angle from the vertical, guys. I am the angle is right here. This is the angle. So if it's like this, the angle is what? 0, right here underneath me. At 0. Now I want you guys to go to Fig 4.1, page 40. We're going to get a number from there. Fig page 40, Fig 4.1, please. This will be on your test, and this is, if you follow with me, you're done. You aced it right away. Okay, without the fig here, without that figure, can you guys see that? Without this figure, good luck doing any calculation. Okay, now, Kerry, my friend, can you tell me what the angle at point 1, please? 0? 0. If you guys go to page 40, Fig 4.1, what is the candela power from the table at angle 0? Can you guys see that right here? Let's go to 0, angle 0. Can you guys see the angle 0 here? What's the CP? CP is candela power, lumen. What's the candela power at 0? 650. That's the isometric curve that comes with the fixture. You have to have an isometric curve. Otherwise, good luck. You can't do it. Okay? So that's your isometric curve that comes with your fixture. Okay. And by the way, why did I use this curve? Because this information is coming for that particular fixture here. Okay, anybody? I want thumbs up. We fully understand where the 650 came from. Everyone? Cool. 650, right from the table. Okay, then, now when you find the angle and the candela power at that particular angle, the rest is history. Done, done, done. So let's go. Here's a formula. So then this is going to be your step number 1 to do. Step number 2 is to plug everything in the formula. Here's my formula. CP times cosine raised to the power 3 multiplied maintenance factor divided by height squared. Plug them in. CP is candela power, that's a lumen. Cosine 0 is what? You guys remember cosine? Cosine 0 is 1. Do you know how to use the cosine now? Do you guys have a scientific calculator? That's the only thing you need to know. Just a cosine. Cool? Grab your scientific calculator. Cosine 0 is 1. Raised to the power 3 multiplied by the maintenance factor. Okay? Let's go ahead. 650 times divided by 10 to the power 2. Now 650 times 1. Where the heck is the 1 came to be? It's cosine. Cosine 1 raised to the power 3 is 1. 1. Chad raised to the power 1 million is Chad. Same thing. Okay. They multiply by 0.5, 0.9 divided by 100. Is this right? I have a feeling that.
Yeah.
I don't know if I multiply the 0.9. 5.9. Okay, 5.9. So the foot candle right underneath the fixture is what? 5.9. See how hard that is? Is that, talk about science? Is that hard? Any comments, any questions? Any comments, any questions? So the light, Jamie, my friend, right underneath the fixture, you're going to get 5.9. Is this average? No, this is a point. This is not an average. Unlike the method before gave you the average, this is not an average. You have to find the average. Okay? Can I flip to calculate for point number 2 when you guys are done? The 10 is the height of the fixture, the mounting height. And 10 times 10 is 100. The bottom here, H, is the height, the mounting height of the fixture. Can I flip to the second one when you guys are done? Cool, cool, cool. So next, I found 1 point. I need to find 3 more. Same way. Let's go to the next one. Okay, now, foot candle at point 2. Foot candle at point 2. Now, Q at point 2 is 45. Where the heck did I get the 45? I have to give you that, guys. You guys see where point 2 is? Can I get you to see where point 2 is? Can you see the angle here? What's the angle? 45. Okay. Everybody got where the 45 came to be? Okay. Point 2 at 45. Now, can you guys go to Fig 4.1, page 40, and verify that the candela power is 112.03? Anybody? You need to, when on the test, guys, I will give you a copy of this graph, or you can go directly to the book. So at 45, everybody can see 45. It's 12.03. Aaron, does it make sense? Is it 12.03? Verified? Okay. So the candela power at this angle is 12.45. It's higher than what it used to be. Okay, so you plug 12.03 cosine 45 raised to the power 3 multiplied by 0.9 divided by 10. Now, how are you going to do that? You're going to take 45 cosine it, then cube the cosine. So here's the 12.03 multiplied by cosine 45 is 0.707, right? Raise this to the power 3, multiply by 0.9, divided by 100, and up it goes with 3.85. See how hard that is? Isn't that a piece of cake? Did they make you thirsty, Jeff? Too much work? Is it? Very easy. Very easy. Any questions about this? That's point 2 for you. The only thing you add on, my friend, you need to make sure always go to the fig 4 point or whatever fig I gave you, right? Find the candela power at that angle and then plug him in. Aaron, my friend, make sure first you get the cosine, then you cube it, right? I need thumbs up that we fully understand this process. When you guys are done, guess what? We're going to go flip to 3 and 4 and do them exactly the same. Can I flip? Flip whenever you want to flip, Chad. Okay. Can I go to the next one, please? Yes, no? Okay. Let's go to point 3. Now, point 3, you guys know where point 3 is. I'm going to go run very quick and show you where point 3 is in the graphic. Here's point 3. Point 3, what's the angle from the vertical of point 3? Aaron, 65? Okay. So without the angle, you're doomed. You can't find it. Okay, let's go all the way. Point 3. So Q is 65. If you guys go to the graphic, the same graphic, you're going to find what's the candela power at 65? 3675. Anybody can you guys verify this, please? 3675. More candela power. Okay. Then the rest is history. You take the 3675 cosine 65 to the power 3 multiplied by 0.9, divide by 10 times 10, all the way. Here's the cosine 65, 0.4226 raised to the power 3, and you got yourself a healthy 2.5 foot candle. A healthy 2.5 foot candle. Now, 2.5, yes. Okay. Do you guys see that graphic 4.4? What is this in visual? Your IES file. Thanks God. That's the IES file that we picked in visual. Does it make more sense now that you did visual before this? Would it be hard for you guys to understand if we didn't do visual first? I'm just wondering. Would it? It's easy to refer to the visual now because we know how to use it. Okay, is that hard? IES file, done. Last one, I'm going to give you a few seconds to write them down. I'm going to go to the last step, step number 4. So we have 2.5. So what are the numbers that we have so far? We have a we have 3.8, we have 5.9, 3.8, and 2.5. Can you guys see that it gets dimmer the further away you go from the fixture? Can you guys see that? The more the angle, the further away you're moving away from a fixture. It gets darker. Makes sense, right? Thumbs up, Chad. Yes, no? Okay, let's go to step number 4. Step number 4 is not there, so I'm gonna go. Well, let's do it together. I don't think we did. I did step number 4 for you. Let me get some. Let's do step number 4 here, guys. Can you? Let's do step number 4. Or you know what? I didn't do. I trust that you guys will do it. Can you guys do it at 25? Can you find the calculation at 25? Do I need to do it? You do the at 0.4. You do the same calculation. Cool. Now we do the same calculation at 0.4. No question asked, right? Okay. Now I want you to tell. I want you guys to tell me though. I have 5.9. I have 3.8 and 2.5. What is the minimum foot candle? 2.5. What's the maximum foot candle? 5.9. What's the average? Let's find the average, right? The average is not found. The average is not found. So let's find, I want to emphasize these ones right here. Max. What was the max? 5.9 foot candle. What's the minimum? What was 2.5? Was it 2.5? 2.5 foot candle. Average. What do you do when you do the average? You take the 5.9 plus 3. What was the 3.1? Was it 3.5? The other point. 3.8. 3.8 plus 2.5. Divide them. How many points did I do? 3. Can somebody do that for me? That's what the average is. Take the three of them, average them. I need my A students to give me the answer. 5.9, 3.8 plus 2.4 divided by 3. Gentlemen, 4. Second, 4. So what's the average of this calculation? 4 so far. So far, right? Now, Visual did a calculation for every square foot, square 2 feet, every 2 feet square along the entire room. And when we did it outside, guys, remember how we did it outside? 10 by 10. They took 10 by 10 feet and they did a calculation in every corner of that 10 by 10 square. Okay. Now suppose we have a parking lot, guys. A parking lot, and we have 1, 2, 3, 4 lights. Suppose that green is 0.5 and the green of the other one is 0.5. Right at the point where the two greens cut, what do you think the light from fixture 1 and fixture 2, right where they meet, what do you think they're going to do to each other? Add up. This is there and why when you grab the fixture outdoor in the parking lot and it has the isometric curve and another fixture, and I told you grab that one and overlap it. Overlapping will make them add up here. So the green line is 0.5 isometric curve for each one of them. Where the two match, cut each other, they will get you this right at this point, get you 0.5 plus 0.5 equal what? 1. Can I have thumbs up, Chad? We know, fully understand how lights add up from different fixtures. These are from 2 different fixtures. If you put 2 fixtures next to each other, the point in between them, right here, it will get light from both of them and it will add up. If it gets 0.5 from this, 0.5 from that, it's going to be an average of or a value of 1. I need thumbs up for this one, guys. Here's another one. This fixture is giving me at this curve 3, this fixture at this curve 1. So 3 at this point where they cut, the curves cut each other, it gives me 3 plus 1, 4. So right here at this point is 4. That's what Visual is doing when you guys throwing your fixture around. That's what Visual was doing for you. Can you have thumbs up, Chad? We understand that. Okay, so that's what I wanted to show you for these fixtures. There's a couple of things about, I wanted to show you guys the ratio, distance over mounting height, the distance along over mounting height, typically 1 to 1 or 2 to 1, so the distance twice the mounting height, give you good distribution pattern. So here's the distance between can you guys see the distance between the mounting? The distance is 10. The distance between the fixtures is twice so here's a 10 fixture. Between the 2 fixtures is 20, right? That gets you the best distribution. The ratio of 2 to 1. Distance is twice the height. Let's take an example. Let's take this fixture is 10. What if this fixture was 30? So that will be, you put the fixture here 30, move 60 feet and put the second fixture. Again, you guys are so spoiled. You don't have to worry with these because you know what we did? You didn't worry about the distance between them. You grab them and you make them overlap and you're done. But when they overlap them based on this criteria, is the distance between the fixtures is twice as the height of the fixture. Meaning the higher the fixture, the further away I can plant these poles when I put my fixtures. What's the problem of high fixture though? High poles. Expensive, number 1, and number 2 is what? Light pollution. Light pollution. Your neighbors are going to be suing you because you're shining the light right through their bedroom. Right? Can I get you guys to understand the ratio between the distance along versus the mounting height between fixtures? So it's 2 to 1, meaning the distance between the fixtures, the poles that carry the fixtures, twice as the distance between the twice as the height of the mounting height of the fixture. Cool? That will get you this good distribution. For example, I have a part. These are outdoor fixture, by the way. The rules for the indoor is the same with some modification. Here's my parking lot. I put my fixture right here. Moved. It's a 10-foot fixture. Moved 20 feet. Planted my fixture here. Then to get the best distribution from this point to the end, I want to make sure what? The distance is what? 10. And from this picture to the end, I need to make sure the distance is 10, right? No more than 10 to get the best distribution. What happens if the parking lot keeps going here? You plant another one here at 20. Can I have thumbs up, Chad? We fully understand how we make the distance between the fixtures twice as the height of the fixture as a start point, as a starting point. If you go right now to the way you laid out your fixture, they were slightly different. Don't worry about it. That's a start point, rule of thumb. These are rule of thumb starting point. Rule of thumb starting point. Rule of thumb starting point. Okay, actually I did it at 0.4 here. Right at the end. I knew I did it. Here's the last calculation, guys. The foot candle at 0.4, 25. We came up with 830. Is this what you came up with? Plug him in. You came up with 5.6. At 25, 5.6. 5.4. Maybe the cosine 25. We're not going to fight over 0.2 though. Okay. Any comments? Any questions? Any comments? Any questions? Any comments? Any questions? Now, can I trust that you guys will read the chat? When you read through the chapter, it's confusing. If you follow up with what I did, especially the calculation, guys, that's all I want you to know about the calculation. Don't confuse yourself. That's, if you know how to do the calculation that I did right now, you got your A's. Cool. Any questions? Any comments? So this will wrap up chapter 4, and I added chapter 3 and 4, guys. So make sure you do the homework. The homework for chapter 3 and 4, guys, the test will be from the homework. So please pay a lot of attention to them. Read them. They're straightforward. They're really not hard. Really not hard at all. Okay, so that's all I have. There's a couple of rule of thumbs, guys, at the end. It says, for example, a 4-lamper like this one will cover, to get you 75-foot candle, on average, 75-foot candle, with the 4 lampers, not 3 lampers, 4 lampers, will cover 75 square feet. One of them will cover 75 square feet. So there's a couple of rule of thumb. Luckily, we have visual. We don't have to use a whole lot of rule of thumbs for these. Okay, so that's basically, we'll wrap up chapter 4, my friend. Any comments, any questions for your friend Chad? I'm hoping, guys, the A students and the B will submit all their power layout by Friday. The C and the D and the Fs, they have whenever. Okay, thanks, guys.